In this video, we'll be looking at how to graph a linear inequality. So a linear inequality will probably have both an x and a y coordinate, not necessarily, but in many cases it does. And it shows you everything that both x, let's actually label that, or x-axis and y. It shows you everything that both x and y can be in our coordinate plane. So for example, if I have a linear inequality, y is greater than or equal to 2x plus 3, our graph of our linear inequality will show you everything that both x and y can be in this case. Now, in order to graph this line, or this inequality, we first have to graph the line that it's associated with, the borderline, where it stops. So the graph that we're going to have to do initially is the equation y is equal to 2x plus 3. And that will represent the border for that inequality. So let's go over how to graph that line. If you recall from a previous video, the number here that stands alone is our y-intercept. That's where a graph crosses the y-axis. The number over here, the 2 in this case, is the slope of our line, which we get by doing rise over run. So since our slope in this case is 2, it's actually 2 over 1. For every 2 it rises, it runs 1. So where do we start? Well, we always start with a point that we know, and we know the y-intercept. So we can start there. So in this question, in this graph, we're going to start off with our y-intercept, or 3, where our borderline crosses the y-axis. Now, for every 2 that the graph rises, according to our slope, it runs 1. So the next point on our borderline is there at 1, 5. It goes up again, up 2, and over 1. So the next point is here. We really and truly only need 2 points to make a line, but I've done 3 just so we can have a better look. We can do even more if we're not confident. We can go the other way as well. And then we can join our points. So let's see how I do here without a ruler. Not too shabby, not too great, but we get the point. Now here's an important thing for us to note. That line is actually a part of our solution, since y is greater than or equal to 2x plus 3. So that's a part of our solution. But where's the rest of our solution? Well, since y can be greater than that line, it can be more than that line, it can be higher than that line. So all of the solutions are higher than the line that we just drew, and as well as on the line. So our solutions are higher than the line we just drew. And we can shade that as the solutions of our inequality, y is greater than or equal to 2x plus 3. Now, I always think it's a good idea to check if your answer makes sense. So in order to check if our answer makes sense, we want to pick a point either in the solution, so within this area here, within this area here, we might want to pick a point within this area here and make sure that our inequality works. Or, if we're feeling a little daring, we could pick a point outside of that area to make sure that it does not work. Now, you might notice I was pointing to 0, 0. That's because 0 and 0 are really easy and quick numbers to plug in. So I'm going to actually test that point, 0, 0, which should not be a solution. It shouldn't be a solution, but I'm going to test it to make sure it's not. And if it isn't, then we can be sure that we have shaded the right side of our line, the correct side of our line actually. All right, so let's test 0, 0 and make sure it's not a solution. So our original inequality is y is greater than or equal to 2x plus 3. And we want to make sure that 0, 0, so x being 0 and y being 0, does not work. So y is 0. 0 is greater than or equal to 2 times 0 plus 3. Is that true? Absolutely not. Which means that 0, 0 is not a part of the solution, and we have in fact shaded the correct side of our graph. Let's try one a little bit different. Okay, so in this one, we have the sign less than. Notice it doesn't say less than or equal to, which means that the line y equals 2/3 x, which we would draw as our border, is not included in the solution. So if it's not included, it is still our border, but it's not included, then our line cannot be a solid line. Our line must be dotted. So first I'm going to draw the line so we can see it and we can visualize where our border is, and then we'll make our line dotted. Okay, so we're going to draw the line y equals 2/3 x. Notice there is no y-intercept here, which means our y-intercept is just plus 0. The y-intercept is at 0. All right, so we can start with that point since we know it. And the rise is 2, while the run is 3. Rise over run, remember that's the slope. Alright, so for every 2 it rises, it runs 3. And that's our second point. We can do that again if we want to make sure that we're comfortable with our line. Rises 2 and runs over 3. And we can go the other direction if we want, running over 3 and falling 2. And so now we have enough points to make a line. Actually 2 would have been enough, but I like to be safe. Alright, so again though, that is not included in our solution, which means that it has to be a broken line. So I'm going to just erase parts of that line so we can see that this is a broken line. Broken line means it's not included in the solution. Alright, but going back to our original inequality, it said that y had to be less than 2/3 x. Less than, which means that it's lower than our line, which means our solution should fall on this side. So that is where our solution is. On the bottom, y is lower than 2/3 x. And if you want, you can take any point within that region and check it. Alright, let's do one more example. Okay, so I definitely wanted to throw in an x equals equation in here so you could remember that the x equals equation has an undefined slope, which means our line has to be vertical. So we're going to have a vertical line with an x-intercept at 2. And if you don't remember that, that means you may have to go back and review how to draw a line. Wow, maybe I have to review it because look at my bendy line. All right, let's fix that line. All right, and here we go. Beautiful, beautiful, beautiful. All right, so the question to you now is, should that line be solid as I've drawn it or broken? If you said solid, you are correct. Good job. It should be solid because x is greater than or equal to. That or equal to is important. That means 2 is a part of the solution. It is that line, borderline is a part of the solution. So our line should be solid. Now x is less than that, and so since x is less than or equal to 2, that means our solution lies to the left because it is less than or equal to 2. And you can test anywhere on this. There we go with the New York sounds again. You can test anywhere over here and anywhere over here, anywhere I put a dot. So if I put a dot here, let's focus on this one for a second. X is negative 3 here, which is in fact less than or equal to 2. So we have chosen the right side of the graph, and that's it.